Welcome to myprojectbuzzer.com. Now we discuss about the product for MACS, a highly customizable low latency communication architecture. Next we see the abstract for the product. Network on chip are an increasing popular communication infrastructure in single chip VLSI designed for enhancing parallelism and system scalability. Processing elements connect to the connections topology via NOC switches, which are responsible for runtime establishment and management of inter-processing element communication channel. Since NOC switch design directly affect overall system performance and exploited the communication parallelism, much previous work focused on efficient NOC switch design. In this paper, we present MACS, a highly parametric NOC switch architecture that provides reduced data transfer design and latency, increase the design flexibility and scalability as compared to previous architecture by combined enhancing the several NOC design strategies. MACS is the enhanced inter-processing element communication using circuit switching technique with the minimum adaptive routing and a simple and fair resolution algorithm to maximize the bandwidth utilization. We evaluate the area and performance on FPGA implementations of overall based process. Additionally, we illustrate the MACS low average channel setup latency using 6 network traffic patterns and 8 parallel JPEG decompression core trace simulation. System on chip are composed of multiple processing elements that are typically assembled in an application domain specific architecture with an inter-processing element communication network to enable the processing element to carry out the application task. The processing element and the communication network exploit inherent inter-task parallelism, which typically increases as the number of processing elements increases for efficient system performance. However, the key to maximizing the leveraged parallelism modern and future SOCs is an efficient and scalable inter-processing element network communication methodology. A NOC composed a set of switches and point-to-point interconnect to form a network topology. Example for mesh, tree, fat tree, torus, ring. Switches connected the neighbor switches one of more processing element using the ports, and processing element coordinate take execution over the ports using the control and data message for either broken into packets of streamed over a communication channel. Next we see the flow diagram for the product. Our input data bits for binary data bits to apply to the NOC based hardware platform. The NOC architecture mainly presented in the router architecture and the injection and ejection architecture and crossbar architecture, then additionally connected to the router wire and processing element section, unit section. This processing element section for processed by the every core architecture for our NOC based on the hardware platform unit. The processing element to be passed in the data based on our injection operation, and the ejection operation to be act as a destination based process. And we developed the architecture for using the 2D mesh topology based 3x3 totally 9 router section based on the structure for diagonal linked. The diagonal linked structure represents for the 9 ways communication based on our path side north, south, east, west, and the north, south and east, west that way of communication. And we communicate the on and off chip communication. This communication utilized by the gateway section. This gateway section every 3x3 2D mesh topology router sections and connected to the gateway for one router section to another one router sections. These are the on-chip and off-chip communication to maintain by the overall source and destination based process. Then we focus the adaptive and runtime resource utilization. The adaptive means we establish the path selection based on our required source and column selection based process. We update automatically for overall architecture based on NOC architecture sections. The runtime resource utilization mainly focused by the path utilization based on our requirement in destination path allocations. Then the round robin section mainly used to do the destination allocation at the same input to passing to the single router. The output to be get it into the router one by one. That section to be followed by the round robin section. This round robin section also performed in the diagonal matrix wise. And finally the output to be passed by the output data bits for overall architecture process. These are the final flow diagram for NOC based hardware architecture in on-chip and the off-chip communication based process. Finally, we see the output for the product. These are the output final backup. We developed our project in Xilinx software, and we use the VHDL code for our required NOC type of projects. We implement the projects based on our on and off chip communication. So we develop the single router architecture. Each single router architecture consists of the injection, ejection operation and the router section and the crossbar section. The crossbar section mainly focused by the round robin based methodology. And we implement the overall 3x3 9 router architecture for each 2D mesh topology connectivity, and we implement the 4 kind of 3x3 router architecture, and this kind of communication mainly based on the off-chip communication. This off-chip communication used to do the gateway connection. The on-chip communication mainly used to do the internal router architecture and the topology based connectivity. These are the final design for our overall main architecture designs. Then we go to the simulation based process. In the simulation based process, we simulate the overall main RTL architecture design. This architecture represents a logical diagram and we open the simulate behavior model. If the process is completed successfully, then we go to the simulate behavior model sections. These are the simulation diagram. These are the simulation input. We already represent the source data, source row, source column, destination row, destination column, external source row, external source column, external destination row, destination column, and the processing element data. We implement the same and different kind of data for each and every processing element. The ejection output to be represent for the destination output for each and every router architecture design. First we apply the reset functions. Then we apply the clock for overall architecture. Then run and to set the initial data positions and to run the each 3 clock we finalized, we got it to the output for final output designs. These are the final output for the output section is 39 positions for ejected output section. These are the final destination router. Another router to be initially 0 position for our overall architecture process. These are the shortest path optimization technique for our overall architecture designs. These are the final simulation diagram. Then we go to the implementations. The implementation based process, we implement the synthesis report. Synthesis report, we analyze the first we select the implementation and we go to the RTL diagram. The RTL diagram to represents what are the logical blocks presented in overall NOC architecture. These are the overall NOC RTL diagrammatic representation and the technological diagram. These are the overall technological diagram representation. Then we go to the report analysis. The report analysis to calculate the how many area to be considered for our overall architecture. These are the final output area, and these are the timing summary for our overall architecture. This is the final output for our overall NOC based architecture in hardware platform. Thank you.